Alright, so this is going to finish up the 4.3 part 1 set of notes, which is the theory behind area under curves and accumulation functions. And it's going to look at a couple more examples like the first one we did, the marketing phones example, just because when we solve these, you actually have to solve them using the Riemann sum. You can't use what we're going to do in the next method, which is solving them using integrations. Alright, so we're going to do a couple more examples, and then that's it. Then we're going to move on from the theory and get to the actual solving, which is using the fundamental theorem of calculus, which is the next set of notes. Alright, so suppose I have the following information. Alright, so this is the, again, statistical information that we've gathered. T represents 3, 6, 9, 12, 15. Alright, f of t is 32, 25, 21, 15, 0. Alright, use the right-hand, left-hand Riemann sum to estimate the total area under the curve. Should be f of t, not f of x. So f of t from 3 to 15. Alright, so we want to find the area. So this would be, if I drew my function, that would be 0.1, 0.2, and I'm not going to. Alright, what I'm going to do is sort of represent what we do, right? We draw rectangles between my 3, my 6, my 6, my 9. So I would have rectangles drawn between these values, alright, if I drew the picture. Alright, either using left hand or right hand points. Alright, left hand or right hand points. And so we'll start with the right hand side. Alright, so I'm going to start with the right hand side. Get myself some more space since I didn't get myself a whole lot of space there. Alright. And so what we're going to do, when I want to do the right hand side to approximate my area. And so the width, I need to figure that out first. Well, the width of each of my rectangles would be my change in time. Well, the width here is 3, right? I go 3 to 6, 6 to 9, 9 to 12, 12 to 15. And so there's 3 units between each of my rectangles. All right, so the width is 3. All right, the heights, all right, this would be the heights, would be my function values. All right, starting from whichever endpoint I'm starting for. So if I'm starting on the right side, this is where I would start. I would draw my first rectangle at 10, then my next one at 15, then my next one at 21, and then my last one at 25. And so if I were to draw them, those would be my heights. And so on the right side, my height would be 10, 15, 21, and 25. And so when I do my right sum, there would be 4 areas, right? Area 1, area 2, area 3, area 4. Alright, area 1 would have a width of 3, and then area 1 using the right side of my rectangles. Well, the right side would have a height of 25. Alright, then the next one would be 3, and then 21. And then the next one would be 3, and 15, and the last one would be 10, and 3. And if you want to, you could factor out the 3 and then do it. I'm just going to multiply it out as is, and so my right sum would come out to be 213. Alright, so the area would be 213 on the right side. Alright, so that's my right sum. Alright, now my left sum. Again, I'm going to add up 4 areas. Well, my left sum, so my rectangle, my width is still 3, that's still true. The heights, though, are now going to come, so I'm going to erase this. Because if I'm on the left side, right, meaning I start here, this is where I start if I'm on the left side, and I draw my rectangle this way. Alright, that would be my first area. Then I draw using my left side, and then my last one using my left side. And so those would be the heights that I would go up. I'd go up 32 on my first, 25 on my second, 21, and then 15. Leave off the 10. The 10 would be on the rightmost rectangle. And so my left sum would be 3 times 32 plus 3 times 25, 3 times 21, and then the last one 3 times 15. And there are my 4 areas from the right side. And again, you could factor out the 3 and add them up, but I'm just going to add them up as is. And so that's going to come out to 279 And so that would be my left sum. My actual area would probably be somewhere between the two. All right, so use the right. So again, actual area would probably be less than 279, bigger than 213. Or you could average the two out if you want to. It should come close to the average. Didn't ask you to average, so I'm just going to leave it. Just ask for left hand, right hand sum to estimate the total area. So the total area should be somewhere between those two values. All right, the last example, again, is similar to that. So again, suppose I have a tech store that found the rate of sales in hundreds of dollars per day for a new iPhone T days after it went on the market. So this is a lot like the first one we did. All right, so T is the number of days, so 0, 7, 14, 21, 28. The rate of sales would be 45 phones per day, 4,500 phones per day, 4,800 phones per day, and so on. Compute the Riemann sum using the left and right hand endpoints. All right, to estimate the total sales over the first 20 days. So again, area is what estimates the total sales. All right, so first of all, when I draw my rectangles, I draw it between my values. So those are really, all right, 7 to 0, 0 to 4, 7 to 14, 14 to 21, 21 to 28. And so the distance between them, right, the width, which is my change in time, is 7. All right, so each of my rectangles has a width of 7 units. If I do the right-hand sum, all right, the right sum means I start on the right side, meaning I'm using 42, 36, 55, and 48 to draw my rectangles. And so when I add up those rectangles, there are 4 of them, right? Rectangle 1, 2, so 1, 2, 3, 4. Area 1, area 2, area 3, area 4. And so it would be 7 times, well, the first rectangle is drawn at 48, so 7 times 48. Next one is 7 times 55, 7 times 36, and 7 times 42. All right, and that simplifies when I multiply that out and add them together. 1,267. And remember, it's in hundreds, and I'll write the hundreds when I get to my final answer. All right, so there's my right sum. All right, now my left sum. Still 4 rectangles. But this time, so I'm going to erase this. This time using the left side. Alright, so the left side means I start at 45, then I use 48 to draw it, 55, and 36. And 36 is the last one, right? Going up, come down, and that's my last one. And so those are the 4 values that I use when I'm drawing my left rectangles. Alright, so 45, 48, 55. And so the first one's going to be 7 times 45. The next one's going to be 7 times 48. 7 times 55, and 7 times 36. And then simplify. So my left sum comes out to be 1,288. Alright, so the actual area would be less than 1,288, bigger than 12,067. And so remember what this is: compute and estimate the total sales for the new iPhone during the first 28 days. So what I'll probably do is, to estimate it, I'll average these out. So I'll average them and use that as my estimate, keeping in mind it's in $100 per day. So my answer is actually in $100 per day. All right, so I'm going to average these two out. So I'm going to take my 1267, add to my 1288, divide by 2 to get an estimation of the two. Comes out 1277.5. So my estimation is that the sales will be about, again, remember it's in hundreds of dollars, so I'm just going to multiply by 100. Alright, about 127,750. All right, that's about, again, it's an estimate, so the term about, that's about how much I would expect them to make in sales over those 28 days. All right, we'll stop there. Again, that's about as much as you have to know. The basic for the Riemann sum is you should be able to do a simple case like the last two that I did. And really, it's understanding where it comes from. It's understanding that the limits of my Riemann sum is really the sum of my function values from point A to point B, right, the accumulation of my function values. And so that's going to lead us into the next set. The next set is sort of the big idea, the fundamental theorem of calculus. All right, so the next set of notes is key. All right, it's the big idea in chapter 5. All right, and so we'll get there on the next set of notes.